Hey everybody, this is Larry. This is me going with Q2 of the weekly contest 216, smallest string with a given numeric value. So this one is greedy. You have to figure out how to be greedy, and in these kind of problems, especially the lexicographically smallest string, where the sum is to some small number. So the question is that I would ask myself is, well, for every character, can it, so you just literally ask yourself in a greedy way, can the first character be an A? Can the first character be a B? Well, okay, if the first character could be an A, then you're done, because you're done with that first character, and then you go to the next character. Can the first character be an A? Yes. Or can the second character be an A? Yes. Can the third character be an A? No. Well, then can the third character be a B? No. Can the third character be a C? ... right? So that's basically the idea. All the string are going to look some variation of this, but it's just about implementation, and it's about getting it right as quickly as possible, especially in a contest context. So basically the idea is, and I have this function that's a little bit weird to look at, but the other two loops should make sense, which is that we go through this index one by one, we check every character, and this is our satisfactorability function, where we can calculate we have enough characters to do the rest of the string in some way. We don't care how they do the rest of the string, as long as they do the rest of the string in a good way, right? So X is from 1 to 26 characters of the alphabet. Here, well, K is just the sum that is left that we need to accommodate. And here's the funky part that, that's the meat of the problem, which is that n minus index minus 1 is just the number of characters that are left. And then if the characters that are left times 26, meaning that if they're all, let's just say in a greedy way, if the rest of the characters are all Z's or Z's, can we still create a string with this sum or greater? And if the answer is yes, then we just put it here, because we know that if we just put a Z on all the other characters, we could still find K somehow. So that's basically the idea here. And then, we add that character back to the string, and then we just, subtract that from the current leftover total that we have to add up to. Yeah, so, and you could do some proofs to show why this always works as a, what I would consider is, as a way to kind of learn about this more. I mean, I'm giving you the idea, but the way to learn about this more is just try to figure out the invariants that come in, the two loop invariants, or the two loops, right? There's a loop invariant here, which is that index is less than n, but how does that relate with the satisfiability function, right? Well, it goes down by 26 every time, give or take. Well, actually it goes down by, and this is just obviously one character at a time, and how does this change with this function, right? So those are the things that I would think about and try to visualize yourself, draw pictures of yourself. I know some videos do it for you, but I want to encourage people to kind of try this, especially on a problem that's slightly easier. This kind of way of thinking with respect to this sort of greedy does come up all the time, so definitely recommend make sure you understand it and practice it. The understanding part, right? Because the coding part is like 10 lines of code. You type it, you're like, okay, I got this, it's done, right? But now, like, the understanding part is the hard part, right? Because, okay. Anyway, that's all I have. What is the complexity of this algorithm? Well, n is the length of the string, and alphabet is, or alpha is the size of the alphabet. So then this would take 26 times n, which is alpha times n, or O of alpha times n. You may say that n is actually not the input size, so we could talk about what that means another time. But yeah, in terms of space, well, you can't do better than returning the result, so that's going to be O of n, right? Cool, which is not linear, by the way. Okay, that's all I have for this problem. You can watch me solve it during the contest. Now, except for one more thing. Yeah, my computer was crashing during the contest, so some stuff is definitely a little bit like, I just lost like a couple of minutes there as a result. But yeah, let me know what you think though, and I will see y'all next problem. Oh wait, watch me solve this, whatever. Mm-hmm. Okay. Mm-hmm. K is a total, right? So, okay. K times 20. Okay, let's step back in the math. If x plus k. K is not look. Um, one. My computer's lagging. My computer's crashing. Oh my god. Come on. Well, there we go. This is not right. Basically. My math is really bad on this one. So do 1, get 1. Okay. Maybe I could have done more testing. Okay. Thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know if you have any questions, because I will always listen to questions. It allows me to, explain future prompts as well when I realize what people are asking and thinking about. Anyway, I will see y'all next week, next contest, next problem, wherever you are. Bye-bye.